Alright, when the last video ended, I had just finished making the X control, which also becomes the consumer for the dataflow programming that we're going to do. So now I want to start making the producer, which I'm going to immediately save to sin.vi. And I also want to change the pattern to a nicer 3 input, 1 output layout. And I also want to change the icon by making a screen grab of the sinus function and pasting it here. I can make this one look as if it is a sinus producer. Now I'm going to need 3 inputs, all numeric. Named start, named iterations, and named end. Iterations is going to be an integer, and I might as well wire them while I'm here. Now this is also where I'm going to create the so-called number flow, and that's also what's going to be, no, not like that, like so, the indicator. When I making this queue now, actually want to find a good way of creating a name. I'm going to be a bit lazy, and therefore I'm only going to go to the application and pick up the VI server reference and keep it as this VI. And I'm only going to pick up the VI name, which happened to be a bit outside the screen. But that's going to become the name of my queue. Now there are some other stuff I want to do here as well, but I can't do it directly in this VI, since I want to send the name of the queue to the X control. Therefore I'm going to go to application and choose start asynchronous call. The VI that I want to start asynchronously, I'm going to call sin_loop, and this is going to become the actual caller that handles all the message sending stuff and whatnot. And this one too is going to need some number inputs. And on top of that, it's going to need a string input. That is the queue name. And why not choose a slightly more agreeable pattern as well? something with 4 inputs. I'm not going to need any outputs since this will be a fire and forget asynchronous VI. Because of that, there won't be any collecting of output from this VI. So I'm going to make the first one name, then start, iterations, and end. With the name, I want to create a queue, or rather obtain it. From this queue, I want to retrieve the message enqueuer that I'm going to use for, or rather the caller is going to use to send messages to the actor. And after I retrieved the enqueuer, then I don't need the queue anymore. Iterations, of course, is going to be the number of times I want to send messages, and this loop is going to take care of that. And in the message queue palette of the actor framework, I have the enqueue VI. And since I'm going to send over a message enqueuer, I can set the data type of the queue, and then I can dequeue the enqueuer like that. I'm going to need some numeric stuff, which is going to look just the same as the operations that we looked at in the introduction. So hopefully I'm going to wire everything correctly now. Like so. And just to make everything work in a leisurely pace, I'm once again going to add a delay of 50 milliseconds. Now it's of course the question, how do I send this double value to my actor? And for that I need a new class. This class is going to be called number message. And it's going to contain a single double value. And to write this value, I'm going to need a single VI for data member access VI. Oops. So here value, write, and nothing else. Create. And here it is. Now this, of course, I can't send this number message class directly. I have to go to properties and choose inheritance and choose message.lv class. Once that is done, I can drag and drop my number message here and the right value VI. And then wire it to my enqueuer. As you notice, there's no red triangle here indicating a typecast for the subclass, and I think that's because a typecast in this case isn't actually needed. The functionality of the enqueuer can handle the subclass as it is, and it doesn't need to be typecasted into a more generic class. When this loop has finished, I want to tell the actor that it can finish running. And for that, I'm going up to the actor framework palette and dragging and dropping the send normal stop VI into this VI and hooking it up to the enqueuer. Like so. But as you can see, there's still something missing here, and that's because we have to tell the message class what it should actually do when it's being sent to the actor. Therefore, I'm going to the number message class item and right-clicking on it and choosing new VI for override. And as you can see here, there's a star in front of the do.vi item, and that's an indicator that it must be inherited. So I'm going to do that, and some stuff happens. When this message is sent to the actor will automatically call the do.vi member VI. So what's coming in here is the actor which in case is the number actor, and number message, which is the message that is sent. So in order for this to work, this message class is going to call the actor class, since the actor class keeps the information about the other items, mainly the chart reference. Therefore, I'm first going to go to the number actor class and drag and drop it here. And then go to the application palette and choose to more specific class, because I want, since this actor that comes in is a number actor, I'm going to make a typecast so that I can use member VIs of number actor. And in this particular case, I want to create a new member VI for the number actor, which is going to be called receive value. And this value is going to be the number that will be sent to the chart. So I'm going to accept a number actor as input, and also the value. And from the number actor, I want to unbundle the class and get the chart reference. And right-clicking on the connector, I want to go to Create, choose Property, and now it's out of the screen. So let me rearrange that and choose Create again, Property, and well, it's still out of this outside of the screen. I'm sorry about that. Now let's see if I can get it. Well, it's barely outside of the... Let me do this instead. There are two properties for setting a value. Either I can set the value directly, or I can set the value with signal. Signal means an event is going to be triggered that when the chart is updated, typically the update event. And I prefer complete functionality, so I'm going to choose the value signaling and wire it thus. And that should be it for the receive value VI. Now I can drag and drop it here. And I'm going to unbundle the number message, and then send the value to the actor like this. Now, as you can see, the scene loop.vi is runnable. So I'm going to save and close that and go back to the scene.vi block panel. I'm going to need some things from the application palette. I want to open a VI reference, and I also want to close a reference. Now, the reference I want to open is, of course, no, not a control, constant, the scene underscore loop.vi. But there's some more things needed to be able to run this. I need to tell the asynchronous VI starter that it's a fire and forget VI. I do that by setting the options to hexadecimal 80, and I want to specify the type as well, and I do that by setting a constant and then dragging and dropping the scene loop.vi onto the constant. And as you can see, this is now acceptable to run. So what I need to do here is only to wire everything that the asynchronous VI needs. And now there's actually only one thing left to do before I can test this. And that is to do some cleaning up in the number actor class. I need a VI for override, and I need this stop core VI. This VI is going to run when the actor stops, and I want this because after everything is done, I'm going to delete the message queue that I never used. Now, this cleaning up for the message queue, and also even for this reference or this queue, they aren't strictly necessary for LabVIEW. There's going to be a slight memory leak if I don't do it, but it's a one-time leak and it's going to be fairly small. LabVIEW's garbage collector is quite smart and will usually detect things like that, but of course it's good form to clean up after yourself. And now to the testing. On the front panel of a new VI, I want to drag and drop the chart. And on its block panel, I want to drag and drop the sin.vi producer, which I notice don't have the appropriate output, which it does have now. So I want to connect this together, and I want to create a constant for the start, starting at 0. I want to create a constant for the number of iterations, and then I'm going to go to the numeric panel, dive into the math and scientific constants palette, and choose 2 times pi. Now, before I start this, there are a few notes. As you can see, I will run the sin.vi. It will run through, start the asynchronous call, and then exit and return the number flow object. It will pass this to the chart, and then this testing VI will stop and return to edit mode. This is why in the sin.vi I have to create a name for the queue and not pass the queue reference itself, because when the main VI stops, a queue reference would have been deallocated and I would have an invalid reference. Instead, I get around that by naming the queue that I want to use. But there's another problem as well. In the chart, I'm starting an actor, and the launch actor VI will also call a start asynchronous call function in order to run the actor, just as well as I'm doing here. But because this main VI exits quite quickly, there seems to be some flaky execution regarding this asynchronous call. It seems like it starts the sub VI sin_loop, but it's not running properly. Because of that, I'm going to use one workaround. And go to create property and see if I can actually get this inside the screen. If I go to property, execution, and it's just outside of the screen, but there's a property called exec state. By checking this one, I can make sure that the asynchronous sub VI is running before I leave this VI and return to the main VI. So I'll right click on the exec state connector, and here I'm going to choose running, and just put a while loop around this. Go to the comparison palette, and here make sure that my sub-VI is running before exiting. Once that is done, I can finally test this pure data flow and see how it's doing. And as you can see, here is my sinus curve, and during this time the VI was staying in edit mode. Regarding error handling, a peculiar thing about X controls is that if there's an error inside, for example, the chart, then the X control will fail silently. Therefore, if you want to catch anything that's happening inside an X control, you need to put some sort of error dialog inside the X control, like so. Also, a drawback of asynchronous sub-VIs is that if there's an error inside one, you probably will not get an error, but they will still continue to run, meaning that you will have a running VI in memory that is locking up parts of your system or causing memory leaks or trouble in other ways. Therefore, one way of handling errors in asynchronous sub-VIs is to make sure that their front panel is opened. For actors, that is simple. You simply create a constant for open actor core front panel and set it to true. It's a bit more tricky for your own asynchronous VI. Inside sin.loop, what you can do is to again find the VI server ref, and from there you create method, and for the front panel choose just outside of the screen open VI. Set the state to perhaps standard, and you can choose to open it in the background or in the foreground. I usually prefer background. Then on the other side, duplicate the method, but instead of choosing open, you choose close. And now the front panel for the sin_loop.vi front panel will stay open during execution. And hopefully that will aid with debugging or closing down the VI should anything happen. Thank you for watching.